So this webinar today, let's officially get started. Brought to you by ISSA and 3M. It's a pleasure to have this topic today, unlocking savings and improving cleaning performance, the importance of accurate chemical dilutions. But at this time, I'd like to welcome Ed Michaels. He's with 3M, and he will introduce our speaker today and keep an eye on things and share with you the content that you're going to enjoy. Ed, it's all
All
yours.
right. All right. Thank you, Jeff. My name is Ed Michaels, and I'm a marketing manager at 3M. I have the pleasure of introducing Zach Dobler as your featured speaker today. Zach is an application engineer specialist at 3M, otherwise known as head janitor, where he brings extensive experience and expertise in cleaning and disinfecting chemistries, along with chemical management systems. He's got a decade of experience and comprehensive knowledge. And Zach has been a key contributor to 3M's success in delivering cutting-edge solutions in surface care. So before I turn it over to Zach, I want to let you know that you can ask questions throughout the presentation via the chat. At the end of the presentation, we will have a Q&A session to address those. If something comes up that's really pertinent to a particular slide, I'll try to jump in. But again, thank you for all coming. We appreciate you taking the time out of your day. And with that, here's Zach.
Thanks, Ed. Thanks, Jeff, and thanks, ISSA, for allowing us this opportunity to speak to you all about an important topic, one that's near and dear to our hearts, and really the reason why 3M, at least, is in the cleaning or chemical management business. Unlocking savings and improving cleaning performance, there's no joke. There's no hiding behind it. That's a big reason why we utilize chemical management in the first place. And unfortunately and fortunately, I believe we're moving a little bit away from the spirit of chemical management systems. So in this webinar today, as Ed mentioned, please include any and all feedback, questions. We'll get to it at some point on this journey here over the next hour, speaking specifically to chemical management systems and why they're so important for our day-to-day in any facility, in any vertical, ranging from healthcare, education, hospitality, and the list can go on here. But without further ado, Ed introduced me. My name is Zach, from the lab here at 3M. Application engineer is a unique way of saying tech service. So the liaison between our smart chemists in the lab and our sales force and customers like yourselves. Super stoked to be on this call with you today and talk a little bit about chemical management, trends we're seeing in industry, as well as what 3M's doing in this space to make this world a better place. So without further ado, we'll jump right into the topic of today. You might think I'm a little crazy though. I'm showing you vehicles. I thought we were talking about cleaning. I thought we were talking about chemical management. Well, it all makes sense here, but I love analogies. I mentioned I'm from the lab here, and pictures help me see things, help me bring things to real life. I had the opportunity earlier this year to kind of travel the country and meet with different customers across many different verticals. But one trend was really true and actually spoke to me quite a bit in the relation to chemical management, and that's traffic. I think we can all say that it's frustrating. It's something we can't plan. It's an area of focus with our vehicle. We know when we're sitting in traffic, our gas mileage is probably going to stink. We're probably going to be spending more money. We're going to have to be taking more trips to the gas station and opening our wallet there. I think when we look at this picture specifically, we would all be of the mindset of I'd rather not be sitting in traffic than sitting in traffic. If I could see you raise your hands, I guarantee we'd all say that. But bringing this to the focal point of why it's on this slide, why I included it in my presentation, this has a lot of synergies with chemical management. If you have a chemical management system that's not operating appropriately, you can't plan on how much chemical that you're purchasing or bringing into your facility, how much you're going through. So your spend's going to go up. Your cleaning performance, the efficiency of your dispenser, maybe those disinfectants meeting the claims that you want to be, they're all going to be suspect because it can't accommodate for that water flow. Now, when we're thinking about a gas engine, Venturi technology, which a lot of chemical management systems operate on, are very similar. So think about this vehicle. When we're putting it through the stress of traffic and having to start and stop, go or not go, the gas that's going into that engine is very spurt-like. which speaks to why our gas mileage is always struggling, why we need to spend more. So with that in mind, hopefully that analogy helps a little bit here. That frustration that we're experiencing in traffic is very similar to this, and it is a synergy to chemical management systems and how they operate with water. Another fun example, just to get us all lighthearted today. Do you think this dog is very efficient in drinking this water? Absolutely not. It can't accommodate for that water flow, water pressure. So mainly it's doing this for excitement. But if you're thinking about chemical management, bring it a little bit more real life. If you have a really intense water pressure and your system can't accommodate for it, do you think it's really diluting what you need it to? Probably not. This brings us to this focal point. Consistency is key to unlocking your optimal performance. And that doesn't matter whether you're driving a car, whether you're cleaning a building, it's all going to be the same. That performance is all built on something being very consistent. Now, getting more into the cleaning space, when we talk about industry observations, or what are we seeing here from my technical service application engineering lens, we're continually inundated, whether it's us or other manufacturers or our customers speaking up in front of us. We're constantly hearing about new products, new disinfectants specifically, more effective cleaning solutions, more sustainable solutions, improved experience or handling, and maybe this is going to help me with my labor challenges. All great things that we love to hear. And it's human nature to love new things. But I really want us to ask this very simple question. In the cleaning space, why is our current solutions not working for me? Is that dirt that I experienced 20 years ago, 10 years ago, maybe last year, any different than it is right now? Are those germs built of different cell structures where my disinfectants are not going to work? Are these stains any different in the carpet or that hard surface? Most likely, the biggest answer to that question is probably not. So what is going on? What's that factor that's happening that's making it that my solutions that I spent a wow, say that fast, pretty penny for, and to say that they're not working for me? A lot of it relates to accurate dilutions. Now, I showed you that traffic picture and talking about consistency and overall delivering product at a consistent rate. Now, looking at cleaning in our day-to-day life, you can see here there's two bottles or two vials. There's a light blue and there's a dark blue. This is another one where if I could be in a classroom with everybody here today, I'd ask you all to raise your hand. How many of you have seen this? I guarantee it's greater than 99% of you have seen a situation where your cleaning chemical is a different shade in color versus maybe the beginning of the shift, at the end of the shift, or day one versus day three. This is very common. And we all know qualitatively from what we can see is that something's not quite right. This is not consistent. And so that speaks to the big point of our conversation today and what we really hope to unlock and discover and jump into a little bit more detail is chemical management. And when we're talking about chemical management, an accurate chemical management system is the most important part of your facility's day-to-day, especially when it comes to cleaning. This chemical management system is responsible for delivering you those cleaning products that you're going to use on your day-to-day to make your lives easier, to kill germs in spaces in a facility, to treat stains, and overall build that experience or profile for your customer's customer as they come in there. So with an accurate chemical management system, as you're seeing on this slide, you can really improve or unlock cost savings, improve your efficiency of the facility. Sustainability metrics can be very much tied into an accurate dilution and overall getting closer to that compliance goal that you have, whether it's regulated products or just a standard of cleaning in your facility. So we really want to bring the forefront to, it's not so much that chemical, it's that chemical management system. We like to build up our team members that are cleaning these facilities. Their jobs are so important. You can be at a healthcare facility and employ the state-of-the-art, the best surgeon in the world. But if you didn't do a proper job in cleaning that space and effectively killing those germs in that area, it doesn't matter that procedure he does. It really matters about how well you clean in that specific area. And a lot of that gets back to things that we cannot necessarily control, and that's the dilution rate with our chemical management systems. So what can impact your chemical management system? A lot of factors, and a lot of factors that we might not necessarily be able to control. We have this very rough sketch of this building here, but this probably speaks to a lot of our customers that are in high-rise buildings or even a building of at least multiple floors. But your water pressure changes. And let's think back to maybe when we were in a hotel the last time, taking a shower. Can you feel that water pressure change when you're in there, when it's operating? Can you hear it? Can you feel it? Does the water temperature change as well? Well, that's a factor of water flow or water pressure. And the design of the building, the age of the plumbing, the location of the dispenser in that building, like what floor it's on, the distance to your water supply, the capacity of your water supply, the number of toilets that are being flushed or how many sinks are being on, these all have an effect on our water pressure. Now, if you're kind of a nerd like me, in the cleaning space specifically, I'd encourage you to go to your local hardware store and pick up a water pressure gauge. One of the funniest things you can do is hook it up to your water source, maybe at the base level of the building, and then take that water pressure gauge and go to the top level. Crank on your water and just watch that bar dance within that gauge. That speaks to the phenomenon of water pressure. And it's always changing. It's something we can't necessarily accommodate for. And if we don't, we're going to feature a few things with our chemical management system. And those are the phenomenons of over and under dilution. So I'll start with over dilution. So too much water. When we're using a chemical management system, the spirit of the chemical management system is to mitigate our user exposure, control our dilution, as well as improve our facility spend overall, because we can consistently know how much we're going to be going through based on a yield on the side of the bottle. Frankly, and me being from the lab, I completely understand. There's always this junior chemist mentality when we're using manual dilution products. So say you have a big 5-gallon jug and it says pour out a 1/2 ounce per gallon. Typically, we reside on this phenomenon of more is better or my concoction's best. That's not necessarily the case. Chemical management systems can help us control that. And if we don't, we're going to feature these two type of phenomenons as well. So over dilution, too much water. Your solution does not have enough of the chemical in it to meet either the manufacturer's specifications or the EPA specifications. And so if that happens, decreased efficacy of your cleaning solution, so by efficacy, the performance of that cleaning solution, and the overall ineffective cleaning ability. And by having ineffective cleaning ability, you're probably going to have to re-clean. So that's kind of why I got that clock down there. You're spending more time going back into these spaces because the cleaning product that, again, you spent that pretty penny for, look at that, I got it, is not proving to be what you needed it to be. And also the bigger reason here, especially in healthcare and in education, is we utilize disinfectants for one sole purpose, and that's killing germs. It's trying to prevent the spread of illness within facilities. And so if you have a cleaning solution that's over diluted or too much water, it may be not where it needs to be from an EPA specification, which is quite scary. So over dilution, too much water. On the other side of the coin, you got under dilution, too much chemical. A big thing here that's not identified in this slide too is safety. When we look at a concentrate, and you pull open the safety data sheet for that, I know you guys are looking at them, they're a riveting read, but you're going to notice those concentrates, the health hazards on them typically are much more severe than the diluted or the ready-to-use product. Now, if you're having too much chemical, you're migrating back towards that concentrate, which is not intended to be exposed to or used when you're using a chemical management system. So too much concentrate, increased cost. You're going to be going through chemical at a lot faster rate, unexpected rate, not at the manufacturer's intended yields or dilutions. So you're going to be going through a lot more product, spending a lot more money. And then a big feature, which we're seeing a lot these days, is excess residue. Some chemistries, we know that when they're used quite often, they make a tacky surface. Well, another factor to this could be maybe your chemical management system is spitting out chemistry that's too heavy or too hot. that could ultimately result in an experience where you're going to be building up a lot more chemical residue on that surface. It feels more gummy. Maybe it's degrading at a quicker rate. If you look at the upper right hand quadrant of this slide, that's a real life customer example of pitting that was happening in a sink, and that ultimately was related to a too concentrated a cleaning solution there. So I encourage everyone, if you have any and all questions, feel free to drop them in the chat. Ed will prompt me if it's worthy of talking about here, but we'll get to it at the very end at the very least. Before advancing, you'll notice I have pH down here at the bottom right-hand corner. Chemical management, the spirit of chemical management is the bulk of today's discussion, but as I talked about with the under dilution phenomenon or too much chemical, we're migrating that cleaning solution to more so the concentrate than the intended or the ready to use dilution. When that happens, we move towards a pH that is not expected or intended to be used. Now, when we're talking about pH, this is a great tool, and it's on every SDS, sometimes on the technical data sheet, for you to analyze or understand the corrosivity or the caustic nature of that cleaning solution or that chemistry in general. Why do I have two peppers on this screen? Again, I love analogies. It kind of brings it home to me here, but let's use this fundamental principle of I'm an alien. I'm coming to Earth, and I was given this vegetable they called a pepper. If I bit into a bell pepper versus a habanero pepper, guarantee I'd have a much different immune response. Would you agree? The bell pepper here, now I'm going to round these pHs just for the sake of time in our discussion. The pH of a bell pepper is around 6. 7 is neutral. The pH of a habanero pepper is roughly around 4.9, so we're round it to 5. So that's like one level difference on the pH scale. Most of us, if we're not super familiar with the pH scale, we may think that, in this example, 6 versus 5, they're only one step away. It's probably going to be a similar response or similar exposure and experience, but that's a big deal. Every step on the pH scale, so every step away from 7, which is neutral, is 10 times more corrosive or caustic as you move on that pH scale. Which, if we're looking this way, we'll use the pepper example. Me biting into a bell pepper, 10 times more acidic in this situation is a habanero pepper. That's going to ultimately give me a much different immune response, and I'm going to be regretting it, probably biting into one of those. Another important feature here about understanding pH that I think is quite interesting is when we look at the different regulatory agencies that we need to abide by. We got the DOT, the Department of Transportation, and we also have OSHA. I'm using these two as a highlight. So OSHA, workplace safety, that's really the big goal behind their intention, and SDSs need to be written and meet a certain criteria requirements per OSHA law. Now, one of those requirements when it's relating to corrosivity of chemicals has a range. And this range is if the pH is anywhere under 2 or greater than 11.5, it's determined to be corrosive. And so that's where you're going to see that corrosive pictogram, corrosive language on the label. And so we're talking about humans and workplace exposure or skin contact, eye contact specifically. Now, when you're looking at the DOT, you'll notice they don't have quite the same level of requirement as OSHA does. Wonder why that's the case. They're saying what's determined to be a corrosive liquid is anything under 4 or greater than 9. Well, OSHA's big concern is accidental release on a roadway. And what's it going to do to the surfaces of a roadway? So they're actually taking a different approach, a different scale, looking at chemicals in a different way of how does this chemical react with the surfaces that it could be experiencing. So I think the reason I think this is interesting and maybe pertinent for this conversation as well is when we're using cleaning chemicals, we think about us and our safety and we wear PPE, but we're kind of disregarding its effects on surfaces and over the abundance of time of using these chemistries on surfaces. And maybe the situation where I applied this product, I didn't have time in my day-to-day, and I'm going to walk away. I'm going to leave this chemistry to dwell on this surface. Now, if the OSHA or DOT, thinks that anything lower than 4 or greater than 9 is corrosive, there's a lot of cleaning chemicals that we use on a day-to-day basis that would be determined corrosive in their aspect. And maybe this is why we're seeing a lot of surface degradation in these spaces. Now, bringing this to a focal point of, okay, Zach, peppers, I get it. That's an interesting analogy. But we're talking about cleaning chemicals. Now, speaking from the 3M lens and the chemistries that we have, we're finding that a lot of our, there's public perception, and there's public perception about third-party sustainable chemistries or putting chemistries in a bucket for a specific example. So I'm going to use floor cleaners. We have a couple of floor cleaners in our portfolio that run through chemical management. Our number 3 are neutral cleaner, and our number 24 are 3-in-1. If I were to strictly look at this by face value and say, okay, I want to use your Green Seal certified floor cleaner, well, you have two options, but you could get in trouble if you didn't know the backstory. And you could also get in trouble if you didn't know the pH scale. So our one on the left here, the number 3, that's a pH of 7. The blue one here on the right, that's a pH of 8 in its diluted form. But from my technical lens and reading the tech data sheet and how we'd recommend products be used to our customers, the one on the right is our heavy duty floor cleaner. And I would recommend to not use that as your day-to-day or your everyday, or else you're going to see surfaces starting to dull, floor finish dulling, for example, versus the one over there on the left, which is a neutral base cleaner that you can use as your everyday. I'm not as concerned based on its functions and components for daily use. So just bring this to a level set. Let's not judge a book by its cover. Let's look at everything from the safety data sheet, technical data sheet, and don't be afraid to reach out to manufacturers. I can speak for 3M, but we have a bunch of us application engineers or technical service individuals in the lab, and what we love to do is help our customers. We love to be transparent, and we love to understand what's not working, what's taking the most time, and what questions you have. I know when we're growing up, going through school, it was always don't be afraid to ask questions. There's no dumb questions. That still is true today, even working our way into the workforce here. So, chemical management, that's still the focus of our topic. How do I validate that my chemical management system is working for me? How do I know if that pH is right where it needs to be? How do I know if that right color is where it should be? Zach, probably there's some regulatory agency that's looking at this, right? Is there a requirement of manufacturers to have chemical management systems that are at a specific specification? I'm here to tell you, as this screen is showing, that's the Wild West out there when it comes to chemical management. There is no regulatory agency that is going out there and saying, hey, 3M, your dispenser needs to accommodate for all water pressures or water pressures between a certain range or needs to work every time you turn it on. And that, frankly, is really getting to why what we're seeing in the industry is the inconsistency in diluted products. We can qualitatively see this when we're thinking about a few slides before and the different shades of blue in those different vials. But when we're talking about cleaning chemicals, specifically with your chemical management system, we're also seeing there's a multitude of different other facets and functions, and it's all relating to the flow or water pressure that dispenser is being experienced to. It can accommodate for it. So if you ever have the privilege to come up to Minnesota and come to 3M corporate campus, we'd love to have you. And one of the factors or demos that we do is run our chemical management systems through different water pressures just to see what happens. And so here's a live example, some pictures of us doing this exercise. On the left here, we have a product that gives you a consistent color, consistent volume, and a consistent SUD profile. So when we say that, we probably think, okay, that's normal. I wouldn't question it on my day-to-day. But you can see 80, 50, 35, and 30 PSI is what we experienced this to the chemical management system. And that's how we got the consistent results. Your chemical management system, I can say, is accommodating for those water pressure changes and giving you a consistent result. Now looking at the right here, this is a chemical management system that didn't behave the same way. 80, 50, 35, 30 PSI, all relatively common water pressures that we experience. And you can see a difference in hue or color, as well as a difference in volume and a SUD profile there. So qualitatively, we start thinking, 30 psi versus 80, there's something not quite right. But we'd always get this question of why? Which one's right, Zach? Which is the right color that I should see? And we'll get to that in a couple slides here. But this is the phenomenon that we're really experiencing in a day-to-day life, is that water pressure is having a big influence on your chemical management system, which ultimately will influence your cleaning and your day-to-day operations, as well as spend. So what type of methodologies can we do that's more on the quantitative lens and more so qualitative in some aspects too? We all kind of know that there are validation techniques out there for disinfectants, and I would encourage us to utilize these for helping us get to the crux of maybe there's something not quite right with my chemical management system, or getting to that point to feel comfortable with requesting your manufacturer to come out and do an audit of your dispenser, or look at maybe what's causing you some headache or concern. So from a chemical validation standpoint, there's two that are widely known in industry. There is test strips and there's titrations. Now, another opportunity, whereas if I was in a classroom with all of you, I would ask, do you like using test strips, and why would you like using them? The response probably back would be, well, they're quick and they're simple to use, and that's super great and super great for validating. But there's one thing about them: the ranges on those test strips are quite wide. So it's not getting you to a very specific metric in terms of it needs to be 400 parts per million. Okay, well, my range is like 2 to 500. I guess it sits right in there. So it's a little bit subjective, not super precise when you're doing your readings, but it's quick, it's easy. You dip it in solution and it turns color, and you have to compare that on that vial. Another factor of this is, hey, maybe you see a color different than your neighbor. And so Ed may see a blue and I may see a green. So that level of subjectivity needs to be also in scope. So whomever in your team who's going to be reading or doing these audits, we just need to be on the same page of what are you seeing on this specific test file, so we make sure we're getting consistent results. Titration kits, another junior chemist mentality when you're using these, very sensitive to shelf life, and it's a drop, drop, drip, drip in a vial, and then you wait for a color change to give you that response of how much parts per million or what that active percentage is of your disinfectant. Again, a little bit complicated. There is a little bit of subjectivity. Why I'm bringing this to the forefront of this conversation is there's no perfect silver bullet method out there for testing dilution accuracy, which is why 3M spent a bunch of time trying to figure out a good method that we can do in facilities to give you a more accurate reading. Now, there's also mechanical validation techniques, dispenser calibrations. That's a common question that us in the technical service team would receive. What's your calibration cycle? Or how often do you need to calibrate your dispenser? That's definitely a common question. And then also dilution tips or metering orifices. How many of us are familiar with these? How many of us love these? I guarantee nobody's raising their hand. So a metering orifice or a metering tip is about the size of an eraser head, and the color usually dictates the size of the orifice size of those tips. And when we're using Venturi systems, like a lot of our chemical management systems are today, you're forcing chemical to go through that little orifice size, meet the water supply, and give you a dilution. So these tips are different sizes for different dilution rates. The common thing with these is they need to be changed, and if they're not changed, you can ultimately impact your end dilution. So these aren't donuts, I promise you. These are dilution tips from a customer account or a real life experience, where they came to us and they mentioned to our sales rep, hey, we got some questions and concerns related to one of our cleaning products. When we first started using it, it seemed to work great. But we're about 6 months in and it's not working the same way. What's going on here? So our sales rep got in contact with someone from the lab, me, and we went out to this account and we looked at the dispenser they're using. We learned they're using dilution tips. And we took a couple tips. We took a brand new tip, and I also took the tip from the dispenser or the specific situation, the cleaning product, where they were suspect of its usage. I brought it back to 3M here in St. Paul, and I put it under a fancy microscope on its end. So that's what we're looking at here. And I quickly was able to determine that the orifice size, So what determines your dilution rate was different than the new one versus the one that's been in use. It's actually quite a bit smaller. And based on doing the measurements, it was roughly 72% smaller than what it should be. So what did that mean for Mr. and Mrs. Customer in this example? What was the response back to them of why wasn't it working quite appropriately? That 72% reduction in orifice size related to a 92% difference or target below the manufacturer's target. So 92% lower or insufficient chemistry was coming out of this dispenser when diluting with this dilution tip. So it wasn't meeting the manufacturer specifications, which ultimately wasn't meeting the expectations or the experience profile that the end customer wanted. So it wasn't cleaning the best it could because it was 92% away, 92% less chemical than needed to do that job that they're experiencing on day one. So we have this ability to do this audit and test, and we'll get into that to the next slide. But the more important factor here, and why I bring this to the forefront, is if you're a customer that utilizes dilution tips or metering orifices, or if you don't know, I'd definitely ask your manufacturer if that is something that they expect you to manually change out or know of. But if you do know that you use this system, I just encourage you to keep changing of these, keep in your routine or your cadence to check these, to replace these, because this will have a drastic impact on your dilution rate. Now, these tips may become clogged, and if they become all the way clogged, maybe just water's coming out of your dispenser versus that disinfectant that we needed. So there are bigger factors than just cleaning performance that are definitely at scope here. And this specific example, we asked the customer, when did you last change your tip? And they said, we didn't know we needed to. So we wanted to bring this to the forefront of this conversation. Now, I see my buddy Ed came on
Hey,
camera
Zach.
here. I'm sure he's got a question for me.
Yeah. One comment was January trip to St. Paul sounds very exciting.
Oh man, yeah. If you guys love cold, definitely come up to
Yeah.
St. Paul in January and February. You would love it. But if you don't, you're gonna stay away. Come here in the summer.
So the other question though that I wanted to bring up quick was, does anyone test the efficacy of ready to use liquid disinfectants that are being used?
Oh,
Kind of
that's a
relate to
great
the,
question.
yeah,
Mhm. Yeah, it's definitely not the focus. So testing. So to Ed's question, ready to use or pre-diluted disinfectants. So when you purchase them, they come ready to go. You don't have to use a chemical management system. So the question is, do I need to test these? Can I test these? Number one, you can test these, absolutely. Do you need to? You really shouldn't because it comes from the manufacturer with a specification, but it doesn't really move the needle away from not wanting to. It's probably best practice to test them. These chemistries are also really sensitive to shelf life. I think that's the bigger focal point here is make sure that that ready to use or diluted product that you purchased is within the manufacturer's shelf life because outside of that, we can't guarantee performance. But test strips are definitely still a validation. Titration kits are still a validation for testing efficacy of those products, and I would connect with your manufacturer of those products for what's the appropriate mechanism to do so.
gotcha. So I know, I forget if you mentioned the part that some chemical bottles have that orifice in the bottle itself. So you get a new orifice every time you get a new chemical. But for those that have orifices that are part of the solution station, do they, do we know what the average lifespan of a mixing system might be?
Really good question. Yeah, some chemical management systems, they have the dilution factor inside the bottle. So customer doesn't need to worry about it. They just every time they change that bottle, they get a new tip. So there it mitigates the tampering, the user error, that whole experience. But those that utilize free tips, so the ones that they manually have to implement or change out to get different either cleaning profiles of their chemistries, different kill claims of their disinfectants, um, there should be a cadence. There should be a routine. That's the quick answer back.
Okay,
What is that routine? Kind of depends on the facility, depends on what the manufacturer intends for their customers to do as well. So I'll defer to them. 3M's not a manufacturer that has manual tips, so I won't be speaking to out of turn there. But I can tell you that dilution tips, they're going to get clogged at some point in the life of the product. If that, and especially so if that when that dispenser is turned off and turned on. So chemical management, those dilution tips, chemicals being forced through one of those tips. When the dispenser is in the off position, the water evaporates from that tip. The chemical that was in that tip still there. So the chemical sits, water goes away, chemical may still be sitting in that tip. As you keep running that, and as that same situation keeps happening, that compounds over time and that tip size gets smaller. So I would encourage you routinely in a cadence that works with your procedures, as well as connecting with the manufacturer of your unit to figure out what's the right procedure. But you definitely need to inspect or replace these tips. And one last piece to that, we've heard from some customers that, hey, I see I have a tip, I know it's the right color, but I don't want to worry about putting a new one in because I don't know when I'm going to get more tips. So I just take a pin and I put it down the tip to clean out any of that residue or buildup. Please do not do that, because that will manipulate that orifice size of that tip size and overall impact the dilution rate of that chemistry. Make it wider, probably make it heavier, and that could be a big problem as well.
Okay. Thanks, Zach. I'll jump off, but I'll jump back in if needed.
No, thank you, Ed. And thanks everyone for the questions. We love questions. That we're here to help everybody on this call in any way we can. So what's 3M's solution? So all this kind of build up here. We have our flow control chemical management system. That's its name. I'll be very honest and transparent. 3M's not creative with their naming profiles for anything, whether it's glass cleaner, I wonder what that does, or chemical management system, 3M flow control. We control the flow of water to each of the chemical quadrants in the cabinet, thus give you a consistent end result. Now, we just got done talking about validation techniques and what can we do? So test strips, calibration mechanisms, titrations, dilution tips. Well, 3M has a method, and it's utilizing math. So it's an outside the box method where we are putting the specifications of that product into a matrix to help us understand how well it's performing. So all those words aside, we weigh a chemical bottle before and after a predetermined volume of dispensed liquid. So, and we take that weight disparity, and that'll overall tell us with our calculator how well it's performing to the specification. So, Zach, in English, please. So every bottle, we pick up a concentrate bottle, and you look at it, and it'll probably tell you, here's the dilution rate. You'll see at one of the sides of the label say, this is the volume of this bottle. It's a half gallon, for example. But another feature that's on there is this is a yield, or how far this bottle is going to go. So if a bottle says it's going 100 gallons per half gallon bottle, a specific amount of chemistry needs to be coming out every gallon to meet that 100-gallon metric, right? So we're able to utilize math to help us understand of how close are we on track to getting that realized yield. So that every gallon, specific amount of chemistry, how are we performing with this test? Are we going to make it to that 100-gallon yield that the manufacturer says it's supposed to be? So we're able to utilize math to get to that equation and plug it into our calculator. Again, this is a different method, and I love examples. This is how it speaks to me too. Pictures and examples, keeping that trend going. This is a real life example with a facility, a healthcare facility specifically, that raised a question to our sales rep in the area. And they basically said this is how this conversation went down. Hey, we're having tacky floors and equipment. What do you think's going on? Can you help me out? And the 3M rep said, yeah, happy to help. What product are you using? So we're trying to figure out what's generating this tacky surface. Customer responds, I'm using a peroxide disinfectant on my floor. We adopted this to try to get away from the infamous quat residue. We have a heavy duty floor cleaner, and that's the only way we're able to get this residue off the floor. What's going on? And so 3M rep said, are you open to doing one of these accuracy tests? So that weighing the chemical before and after, that's what we're referring to in our accuracy tests. Are you open to do an accuracy test to evaluate how your dispenser is operating? Customer said, absolutely. Now, this is a picture of what we got going on here. This is a floor tile with some resilient resilient floor coating. I'll leave that to your imagination. And it looks wet. And when we're looking at this slide, you're like, that looks wet. What's going on here is actually the exposure to this chemistry caused the floor finish to come back to a liquid phase. So emulsified it back to its liquid, gummy self. So putting it on the floor and giving you that protection, it brought it back. And that is what was going on here with the customer. So utilizing this example, they called our technical team and me, came out, and we did one of these accuracy tests at 4 floors in this facility. And across this test, we tested both of their disinfectants that they were utilizing. One of them proved to us that it was 27% heavy. So 27% more chemical than required to meet label claims, to meet manufacturer claims. So they're spending 27% more too, 27% more exposure of this concentrated chemical on the floor. And then this other competitor too, here, 23.5% heavy. And then if I excluded one score that was below the metric, so you can see on closet 4, minus 14.75, it was actually 36% heavy. So this testing gives us a real life example to the nearest percentage how well the dispenser is operating, or how close that chemical is to that specification on that label for yield. How far can it go? So in this example, we were able to tell the customer, well, based on these tests that we found, the disinfectant that you're utilizing is coming in very heavy. And so that's probably relating to why you're seeing your floor finish come back to its floor finish liquid phase surface damage. And why your heavy duty floor cleaner, why you need that is because you need something a little bit more aggressive to remove that emulsified floor finish or soiling from your floor. So this type of test can tell us more than how is your disinfecting coming close to your EPA label spec, but it also can tell us the efficacy of the dispenser as well as cleaning performance as well. So why is 3M in the chemical management business? We really are standing behind the factor of your cleaning chemical does not matter unless it's diluted appropriately. So we've taken this to heart. We put a lot of science engineering behind our dispenser itself, which our customers don't pay for. They pay for the chemistries, not the dispenser, because we believe that tool is one of the most important employees within a facility. You depend on it to dilute appropriately. You depend on it to deliver a solution that's ultimately going to be safer for you to handle. You depend on it to deliver a solution that could be killing the germs in your facility. There's a lot of trust in this chemical management system. So why it's called flow control, I alluded to it earlier. We control the flow of water from the wall to each of those quadrants in the cabinet here. So it doesn't matter where that chemical is located in the cabinet, as long as it's sufficiently screwed in, it's going to operate appropriately because we're maintaining a consistent, again, consistency comes in, consistent flow of water to each of those quadrants to allow that Venturi technology to operate. So with that in mind, and why we have this chart here on the right, by having flow control technology, by having this 3M science, you are going to be 55% more accurate than the next leading competitive system on the market. So again, we may not have the quickest disinfectant in the world, but we're going to be delivering you, by quickest contact time, but we're going to be delivering you a product that's meeting specification, and that's the ultimate goal behind it. So when looking at this chart here, this is in all of our literature. You'll notice that there's 2 bars on this chart, and it says competitor A, B, C, D, and E. I can't tell you who they are from a legal sense, but I can tell you they're the big fish in the sea. And what we're finding out is that even within specifications designed by the manufacturers, there's inaccuracy. And that inaccuracy is speaking to the increased or unplanned spending. It's speaking to the surface damage, or it's speaking to I have to re-clean surfaces, concerns with test strips or titration kits and their overall scores. All this is kind of relating back to, is your chemical management system working appropriately? So before we answer that question of new product, better experience, cleans more effectively, we need to answer the question, how is it being delivered? How is it coming to me? Is it going to be meeting that specification to meet those needs? Our test that you see on this chart here, we did water pressure ranges from 20 to 120 psi. Now, flow control has a specification of 20 to 90. So even out of our specified range, we did this test. We also tested multitude of different dilution products. So a bathroom cleaner, a disinfectant, a floor cleaner, a general purpose cleaner. Why we did that is we wanted to make sure that we were meeting different types of dilution ratios, whether they're lighter or heavier in these spaces. And we tested them in water pressure ranges from 20 to 120. And that these are the results on this chart right here. And this is how we get to that 55% claim. So with that in mind, 3M's really proud of accuracy, and we talk about it all the time, and it's usually the leading focal point when we talk about cleaning chemicals, because again, it doesn't matter unless it's diluted appropriately. But it's not just 3M's talking about this. This was a study by the Cleveland VA Medical Center where they did an analysis of 10 healthcare facilities within their network, and they were looking specifically at automated chemical management systems. So much like flow control here, on how are they performing. They were seeing inconsistent performance. They were seeing suspect readings or calibration metrics, and they wanted to do a study to figure out how this was going. 3M had no influence on this study. We didn't even know it was launched. A customer actually presented this study to us with glowing results here, and the one dispenser that was operating appropriately in their testing was flow control. And we weren't surprised, we were encouraged, we were excited, and ultimately very happy that this was working for that one facility that was using one of our dispensers. But one other reason why I'm bringing this up to the forefront, and we're happy to distribute this study as well, or you can definitely even Google it specifically when looking at the Cleveland VA automated dispenser study. But this study has driven some regulatory advocacy work, I would call it, within the VA Medical Center network. And so because of this study and because of the findings that resulted from this, so dysfunctional dispensers essentially, all VA medical centers are being required to audit their whole entirety of their chemical management systems and determine a method or a remedy of how are we going to get back to utilizing chemical management systems or ready to use diluted disinfectants to meet the needs of killing germs in our facility or providing disinfectants that meet specification. So this study specifically has driven a lot of auditing, a lot of work, a lot of redo, a lot of understanding in the chemical management space. And we believe that this is just the start. And I'm hoping that there are going to be metrics put in place that hold chemical management systems more accountable to operate in water pressure ranges that are more realistic to our environment today. Sustainability. We love to talk about sustainability as well. I'm not aware of a third-party certification that you can put on a dispenser specifically, but maybe there should be. But just thinking through chemical management, what it's supposed to do, the spirit of chemical management, avoid concentrate exposure, plan spending, plan usage, not wasting water, not wasting chemical, not exposing too much chemical and damaging surfaces. So that reduction in chemical waste and water, prevention of surface damage, reduction in packaging maybe, transportation costs being lower because we're using more concentrated products versus ready to use, and mitigating that recleaning effort because the chemicals coming in at the right dilution that we need to, or maybe not too heavy, not too under, so over and under dilution. That can be viewed as a sustainability pillar within a network or within a facility as well. So I encourage us to definitely understand and realize that. But ultimately, your accurate chemical management system is so important. The efficacy of that dispenser, that it's operating, that's working on that day-to-day basis. It's that employee that you can depend on to provide aesthetics of your facility to meet your needs, to build that brand or that experience, the efficacy of your cleaning solutions, protecting your services in your facilities. I know we're asked a lot today, and our budgets are not necessarily getting any bigger, but replacing surfaces isn't going to help. And so I believe that chemical management systems that are delivering product too heavy is going to cause that cycle to happen a lot more frequent rate in terms of having to replace those surfaces. So definitely optimizing your chemical management system can help you in the long run as well, whether that's planned spending, whether that's surface compatibility, and just overall optimizing your day-to-day operations. So I really appreciate the time today. We're now going to open this session up to questions, whether they're entered in the chat or if any that Ed received on a different channel. And any and all feedback's welcome. So this is an opportunity too. If we didn't cover something, if you want to talk about something more, please keep it commenting in the chat. We'd love to hear from you, and definitely don't be shy. So thank
Awesome.
you.
Well, thanks, Zach. Before we wrap things up, just wanted to run through a couple of the different questions that came in. One was around the cost of chemicals and ready-to-use cost versus getting a concentrated product that you might dilute through a system. Are there any general numbers that you're aware of?
Yeah, that's a good question. I'm not aware of a general number, so I don't want to butcher that or mislead.
Yeah.
But it's kind of speaks to itself. Ready to use are going to be more expensive. You're going to use a lot more packaging material. A lot of our concentrate products. I'll give an example. Our floor cleaner, or I'll use a disinfectant as an example. One of our disinfectants goes 110 gallons for a half-gallon bottle. When you're looking at ready to use, you're usually purchasing it in quart quantities typically. So
Okay.
you got a much bigger landscape or runway there with a concentrated product.
Awesome. Another comment in question was around, some disinfectants can be pretty corrosive to plastics and things like that. Are plastics that are used in some of the dispensers designed to handle that corrosive nature of disinfectants, or is there like a specific dispenser designed for disinfectant?
That's a really good question. And I can only speak on the half of 3M, so I can't speak for other manufacturers, but that's part of our testing procedure and rigor is making sure that when we launch a product, that concentrated form is going to be compatible with the internal workings of our dispenser. So I can assure you that the cleaning chemicals and disinfectants that the 3M Flow Control has or that utilizes are compatible with internal workings of that dispenser. Now, I can tell you that plastic and rubber over time, whether that's exposure to heat or flow, or maybe it's just longevity of that dispenser, can become brittle or hard over time. And I can speak for 3M Flow Control. We do have replacement parts for the connection points or the tubing. So when they appear discolored or they get hard to the touch, that's a good indicator. Let's just replace one of those. And it's super simple and easy to do, but just to keep everything going.
Awesome. Let's see, a couple other questions that have came in. Is there a average or allowable error when it comes to the EPA and like a disinfectants, the label concentration that they have? Does the EPA have a range where it's okay to range from 0 to 10% that you're aware of?
Yeah, great question again. And a lot of this is going to rely on the facility's risk assessment in terms of what is the score that they're comfortable with. I can tell you from the EPA perspective, from the regulated side, the specifications need to be at a minimum of that specific parameter defined on the label. So if it says it needs to be 860 parts per million, that's the minimum score. It should be 860 parts per million.
Okay. Kind of related to the tips that some manufacturers use, how long or how often should you replace those? Is there any recommendations that you're aware of?
I'm not aware of one. We're not a manufacturer that requires manual tip changes. In fact, we want to mitigate that from the operation because there's just a lot of opportunity for error. But we do have dilution tips still within the bottles themselves. Us, the manufacturer, puts them in during manufacturing. So our thought process is every time you change out that bottle, you're going to get a new tip. So if I were a manufacturer of a dispenser that did require manual tip changes, I would definitely recommend them to be replaced at a cadence or routine that meets your process, and maybe even at a sooner rate than maybe you would expect.
Okay. Another question, is there an ideal temperature for the water that you're like using with your dispenser? I know some people sometimes think that hot water is going to work better. Can you comment on that?
Yeah, that's a good one. We actually are receiving a lot of questions about that lately, and I'm here to tell you that all of the 3M chemicals at least are tested or meet specification at general tap water, so cool water. We do not require, nor do we need hot water for them to perform. So take that into account when utilizing them as when they're diluted with your traditional tap water, that is just fine. I would encourage our customers to not use hot water with chemical management products, and a few reasons beyond that. One of them is once you dilute something with hot water, 10 minutes later, what is it? It's room temperature. So you kind of just wasted some energy in having to use hot water for that instance. Another big factor here is a lot of our chemical management systems, the Venturi technology, they use tubes, they use plastic, they use rubber. A previous question was related to that. When you heat those substrates up, they tend to get looser. And so just for the longevity of that dispenser and to prevent leaking overall, we say don't use hot water at all. The specification on the 3M flow control unit, I can speak to that, is 40 degrees to 140 degrees Fahrenheit. And you might be saying, well, 140 is pretty warm. It is pretty warm. But we've seen instances where it gets a lot hotter than that, and that's where issues can persist. So I recommend only using cold or tap water, somehow mitigating so that the user doesn't actually turn on the hot water at all is also very helpful.
Okay. Yeah, there's a couple more questions that you did answer throughout the presentation, so I'm not sure if they came in before. I'm assuming so. But one of them is, maybe this is a good one. Why do so many cleaning operations assume the chemical management system is fine when it's costing them thousands in hidden expenses?
Great question. I wish there was a better way to communicate this. I think so when we're diluting a product, we're not given a color code. We're not given like it should look just like this on a day-to-day basis. And with that in mind, it's hard to know from a qualitative standpoint, and it's mainly qualitative in terms of what we need to evaluate for our diluted products. There's not a good test method. I think that at the end of the day, that's the simple answer to the question. There's not a very robust, good test method for the efficacy of that chemical management system. And that's where I think there is a need from a regulatory advocacy standpoint to implement requirements of chemical management systems and better testing metrics for getting to that endpoint.
Great, great. All right. Well, again, we got 2 minutes left, so I didn't want to continue extending this on because I appreciate everyone that's been on here for the full hour. Jeff, I don't know if you have any closing comments or Zach.
No, you guys did great. We appreciate it. Great content.
Awesome. And again, if there's questions that you have, feel free to reach out to me. My email is in the presentation. I'll add it to the chat. It could be sales related questions, or if you have technical ones, I'll route them to Zach. Thanks,
Absolutely.
everyone.
Thanks, everyone. We appreciate your time.